Hi everyone, I wanted to show the answers from the packet, page 13 and 14. So here, pause the video and take a look at the answers. This is 13. And then 14, pause the video and then take a look at the answers. Okay. I want to go through page 12. Some people had questions on page 12, so I want to go through page 12. I know that we did these problems, some of them, but I'm going to do them again so everyone understands how to do them. So it's the population of the tigers. That's what we're looking at. And then they want to talk about what they're asking what 90 represents. And if my expression is 60 times 0.75 to the t power plus 30, when t is 0, you will get the population of the tigers to be 90. So, remember, anything raised to the 0 power is 1. 1 times 60 is 60, plus 30 is 90. Think about how, like, there was this, if it wasn't for 30, the population would be 60. That would be the initial amount. But I guess 30 tigers were added after that, so the population is 90 when t is 0. You can write down when t is 0, population is 90, or you can say that represents the initial population. You can say it's the starting population. You can say it's the population of the tigers in 1980. All right, let's go on to if the population was tracked from 1980 to 2000, then what's the range? Ignore this, please. So the range are the y values. I'm going to make a really quick sketch of this. So it's 0.75. It's decaying because the tigers are dying, so my graph's going to go down. So let me draw it nicer. We know the population at t equals 0, it's 90. There's the y-intercept. This number, let me remind you of the parent graph of something that's going down, like 1/2 x. It's going to decrease, and then the horizontal asymptote is the x-axis, and then the y-intercept here is 1, and it decreases. This 60, which stretches the graph 60 times, is not going to affect the asymptote. What's going to affect the asymptote is this 30. So if that's 90, then this is 30. So this is what the graph's going to look like. It's going to go through that 90, and it's going to hug this horizontal asymptote. Now, the range are the y values. The largest y value is going to keep on going, so for the range, the largest y value is infinity. The smallest y value is 30, but parentheses on the 30, it's never going to touch this line, y equals 30. It's just going to get really, really close. So the range is from 30 to infinity. That's the answer for B. And again, parentheses on the 30, bracket on the 90. C is asking, in the context of this problem, what does the horizontal asymptote represent? Please don't write down the horizontal asymptote, the line that the graph is not going to touch. Don't write down that's the line that the graph is going to get really close to. In the context of this problem, like with the tigers, what does this line y equals 30 represent? So no matter what year we're in, like these are the years, time is on the x-axis, y-axis represents tigers, population. So like year 1, for example, like it started in 1980, so 1981. This is the population, right here. Year 3, that's the population, like whatever the number that is. Then we keep going, that's the population. And then, let me make this go, like year 10, that's the population. The population is going to sort of stay, look how it's staying flat because of the asymptote. The population is going to stay flat at 30. So the horizontal asymptote says that as time goes on forever and ever, the population is not going to go down below 30. The population is going to stay steady at 30. So I wrote down so what is the horizontal asymptote? We know it's y equals 30. As time increases, population will remain steady at 30 tigers. So I don't know if it makes sense in real life, but in real life it's saying that there are always going to be at least 30 tigers. The population of the tigers is never going to go below 30, because the graph hugs the number 30, the y value 30, and the y value represents population. Okay, the next one, the y-intercept. Let me hide this part. Okay. Plug in 0. 3 to the 0 power is 1, so the y-intercept is 1. Or think about, like there's a 1 hiding out here. So the y-intercept for A is 1. Let's go on to B. You think the y-intercept is 2, but careful, you add 1, so the y-intercept is 3. Or do the math out. 3 raised to 0 is 1. 1 times 2 is 2, plus 1 is 3. Here, you know the 3 is the y-intercept. For D, it's the 3 that's the y-intercept. Do the math out if you're not sure. Anything raised to the 0 power is 1. 1 times 3 is 3. So those are the answers. All right, number 3, domain. So domain are the x values. You can think about the graph of cosine of x if you want to talk about the answer or come up with the answer. Remember, it's the skateboard ramp, the skateboard ramp, right? It keeps on going forever and ever, so the domain's all real numbers. X squared plus 7, it's just a parabola that went up 7. Domain, like it's going to get wider and wider, it's all real numbers. Another way to think about it, is there a number for x I cannot plug in? Can I do 0 squared? Sure I can. Can I do 1 squared? Of course. Can I do a fraction squared? Yup. Can I do a negative number squared? Sure. I can take any number and square it and add 7, so domains are all real numbers. C, exponential functions. Is there a number I cannot plug in for the exponents? Nope, because I can plug in anything that I want. Think about the graph as well. Like the 1/4 is going to make it go decrease. The 1/4 is going to make it decrease. 8 is going to stretch it, and the -2 brings it down. So I'm going to sketch it really quickly. My y-intercept is 8 minus 2. It's 6. There's a 6. And then my horizontal asymptote is at -2. And so this graph is going to decrease. This is what it looks like. Oh, it's not supposed to touch it. I got carried away. But look at it from left to right. The domain is all real numbers. The domain of -2 to the x, it's just 2 to the x. This is 2 to the x. It's just 2 to the x that was reflected over the x-axis. Look at it from left to right. The domain's all real numbers. E to the x looks so similar to 2 to the x. So 2 to the x's domain, like look at it from left to right. The domain for all of them is all real numbers. Okay, they want you to find the range for number 4. Number 4, I'm just going to show you the answer. Graphing this, like I already talked about how to graph a bunch of them, so I think you'll be fine. It's decreasing. Does the 3 affect the asymptote? Nope. The +2 moves it up 2. So the range, this is at 2. Look how I found the y-intercept. 3 plus 2 is 5. The y-intercept's at 5. The range is from 2 to infinity. The horizontal asymptote's y equals 2. Number 5, this one is the same problem as a problem that we've done in class before on the graphing page. It's on page 8. Yeah, number 22. I gave you the same problem, so whoopsie. Okay, someone else wanted me to go over another page, so let me go over that. Someone else wanted me to go over page 9. Page 9 is a really good page to look at. I'm hoping I'll go over 26 really, really quickly. Y-intercept for A, it's 2. Y-intercept for B is 4. Y-intercept for C is 1. Y-intercept for D is 4. The y-intercept for E, there's a 1 hiding out, plus the 3, it's 4. So which of them have a y-intercept of 4? We've got B, we've got D, and E. If you're not sure of this, plug in a number, plug in 0, I'm sorry, not any number, plug in 0. Like 5 to the 0 power is 1. 1 times 4 is 4. All right, which of the following is the range? So this is going to be, because it's bigger than 1, that's going to be a growing, increasing exponential function. It's growth. My money is being doubled. And so goes right 7. Let me write that down. Right 7 and stretches by 3. So my y-intercept, I'm going to quickly just graph y equals 2 to the x. Y equals 2 to the x starts at 1 and looks like that. This one, let's talk about where it's going to start. If I plug in, so the y-intercept here, without the right 7, the y-intercept here is, without the right 7, it's at 3. But the 7 moves the graph right 7. So 1, 2, 3, 4, 5, 6, 7. My y-intercept is supposed to be at 0, 3, but that point went all the way 7. All right. Again, this graph is not going up and down, so it's just getting stretched by 3. The range is still going to look like this. That's what the range is going to look like. So the range, like the 7 is not going to affect the range. 7 is not going to affect the y value. The graph goes right 3. The range is obviously, the y values are not all real numbers. The answer is B. All right, which transformation changes a horizontal asymptote? I think I did this in class, but I'll do it again. A vertical shift. Vertical shift. If I move my graph up and down, vertical shift, that changes the horizontal asymptote. If I flip my graph, if I take this and flip it, it doesn't change the horizontal asymptote. It will stay the same, even if I flip the graph. Right or left does not change a horizontal line. If this is a horizontal asymptote, if I move the graph right, it's still the same. So the vertical shift. The domain for any exponential function. It could be seriously super complicated. 100 times 1.089 to the t power. The domain is all real numbers. It can be nice and sweet as y equals e to the x. The domain is all real numbers. Because we can plug in whatever I want for the exponent. Okay, I hope that helps.